right, hello everybody. Please welcome Hazel Weakly, she'll be giving a talk on geology for open source.
Hello, everybody, and welcome to class. My name is Hazel Weakly. I have thoughts, lots of thoughts, and they never stop thinking. They never stop thinking. And I will unfortunately not be your geology professor today. However, we are going to have lots of fun. And one of the things that I think about when it comes to open source is like a lot of software, like a lot of ecosystems, like a lot of communities, it involves this evolution over time. And I'm actually kind of struggled to convey how I think about it and how I conceptualize it until I realized at one point we already have this concept of evolution of this iterative development. And we call it, licking rocks or geology. But we also actually have this thing called a cumulative culture. And so in cognitive psychology, a cumulative culture is the thing that kind of describes how humans, how social groups work together. They learn, they share, they innovate, and then they kind of go to the next level and then build on top of people. It is this sort of stand on the shoulders of giants, or this how can we get here if we started here and human lifespans are so tiny and we're really bad at doing everything that we do? How do somehow we go from humans drool for the first 5 years of their life? But hey, here's a rocket in space. How does that happen? And cumulative culture gets you there. So cumulative culture is a really good way to explain it. And it does tie into geology. We'll get to back to looking rocks, but it does tie into geology. And so one of the things about cognitive culture, it requires a couple different aspects and has a couple different components in how it works. The first is high fidelity transmission. It turns out humans do something particularly unique in the animal kingdom, which is when we learn something via imitation. We imitate it really, really specifically, really, really well, to the point where we learn by carbon copy, almost, of an idea. And it's how synchronized dancing works. It's how a whole bunch of other things work. Rather than embedding that sort of in our, biology over time, we actually just learn by deep mimicry. And so we can transfer very, very complex ideas, sort of almost bite for bite into another person by way of this deep mimicry. Another thing that makes this cumulative culture thing work is there's two different types of innovation. And that's something that trips up a lot of people because they think of innovation. But there's two. One is the shallow innovation. That is the surprise innovation. Someone has this kind of a spark, and it's a weird ass idea. It just kind of comes out of nowhere and hits them. And that can be either a leap, or it can be, a reinvention of something, or it can just be really, really weird. But either way, that's that kind of solo innovation. And then there's the really, really fun one, my favorite one, which is the cumulative culture innovation. How do we innovate by way of sharing, collaborating, learning, doing all these aspects of it? And it turns out that's actually kind of almost the most important one, at least in my opinion. And there's also we learn by teaching. And if anybody has ever said, "Oh, I don't really get this concept," or "I don't know how well I know it," and then someone says, "Well, teach it," and then you'll really know it. And then you go, "What?" And then you try it, and you go, "Oh, I don't know this at all." Like, oh, man. And then you go back and you learn it realistically. And then you teach it again, and at some point, you actually learn it. And you have to kind of learn it by teaching. And it's this knowledge dissemination as a process of knowledge acquisition. It's one of the funnest sort of catch 22s of how humans work. And then there's also, and this is where the geology comes in, we have this recombination. It is deeply necessary for human learning, for this cumulative culture, for us to take this growing expanse of knowledge and chunk it. We need to compress it. We need to take this thing, these loose bits of ideas, and cement them down slowly into a foundation that we can work on top of. That's how culture just kind of works. That's how we are able to build and expand and grow more. And it is the bedrock, so to speak, of what allows for that ratcheting of human collective knowledge. And one of the really cool things about this is if you look at basically all of these items, except for the bottom one, if you look at all these items, you get open source development. So if you think of maybe the fourth items, or if you think of the idea of open source, what does open source mean? How do you do it? How does it work? Well, you have an idea. You try it out. You put it somewhere. People can copy it. They can iterate off of it. They can modify it. They can maybe fork it. They can do a whole new thing. They can get inspired by it. They can share together. They build libraries. They build these ecosystems of, and how we do open source is almost entirely this deeply embedded concept of how humans learn most effectively as a community. We have managed to somehow replicate that naturally in how open source works. One of the strongest arguments, in my opinion, for open source is that it is due to how humans work, sort of arguably, qualitatively, demonstrably, the most effective way to iterate and learn and do software development. That is essentially biologically how we work. If you want humans to be able to get from one point to another and learn that way and rapidly innovate, an open source model is kind of the way you have to do it if you're going to get good results. Like I said, aside from that last one, aside from that recombination, so one of those tricky things about open source is we don't really do that super well. But okay. I promised rocks. I promised rocks that the word geology is in the title. We will get to the rocks. So we have this kind of rock life cycle. And remember how I was saying earlier, how I kind of struggled to come up with a good way to explain how I think of software and its evolution over time? This is actually a great way to think about it. So you have sediment. But before you have sediment, you have people on the surface. And they're going, cool, this is neat. I have flowers. I have rocks and stuff. I have sand. Love sand. Gets everywhere. It's super annoying. But it's great. Okay, now what? And so as you kind of work on top of the surface, over and over time, things trickle down. They go through this, the sand gets compacted, the sand gets cemented, it turns into rock. The most basic fundamental layer of rock that pretty much everything builds on top of. But at some point, that sand that has turned into rock gets even more compressed and even more compressed. And the forcing function of gravity and the earth and the pressure and everything forces that rock to go through a transformation. As it transforms, it becomes magma. It becomes this, somehow we deeply rely on, somehow it's, this fundamental layer, but at the same time, this magma is very, very flexible. When it's in that critical state, a paradigm shift can happen. Oh, sorry, we're still talking about rocks. The magma can kind of do one of two things. It can sort of be pushed back up and be pushed back up, and then turns back into rock. Sort of just naturally, nicely, normally, that's how granite works, or quartz, or most all the rocks that we know and love. But every now and then, the paradigm shift, the rocks, every now and then, the magma reaches such a critical point and there's sort of this fracture in how the bedrock is formed that the magma escapes. And you get this instantaneous evolution sort of concept in the form of a volcano. And so I look at this and I go, what does this have to do with software development? So here's my thinking. We have humans on the top. Humans need tools, they need to share things, they need to build things, they need concepts, they need to do this cumulative culture thing. So we do it. We do it with certain types of bots for the strong foundations, other types of bots for the pretty decorations, other types of bots are malleable, and we build a lot of our foundation, a lot of our society on these concepts, and we decorate it with a bunch of other things that will eventually decompose and become sediment and turn into rock later. And so as we go through and build these packages or these libraries or these tools or these small little, I need to solve a problem and here's how I do it. At some point, your solution turns into maybe a package. And then at some point, that package gets used by a whole bunch of other projects. At some point, that project gets, turned into a sort of a foundational library. And then that foundational library, at some point, people go, this is so foundational that it should be an even deeper concept. We shouldn't really just have this be a library. It needs to be a kernel module, or it needs to be an operating system feature. It needs to be something that we just take for granted. Awesome. So you do that. And then at some point, the kernel module, at least in Linux, the kernel module is kind of where everything just sort of gets hoovered in. It just, all these ideas that have passed that barrier get in there. And it's really, really neat. It's really awesome. But at some point, it may graduate from a kernel module into actually being in the kernel. And now it's not even that, sedimentary rock, it's not very deep pressure. It's so deeply embedded that it's almost inescapable. But once it's in the kernel, isn't that it? Well, things get to build on top of it, which is great. But sometimes it's in the kernel, and even though that's it, some huge paradigm shift happens or some culture happens. And what we think of as belonging in the kernel fundamentally shifts. So, like, for example, eBPF is kind of fun. And eBPF, the E stands for extremely cursed. And BPF stands for a couple packet filtering utilities that everybody thought was a good idea back in, 2005. And then, actually earlier, but who's counting? And then people go, well, what if I took this tiny little concept that we've buried so deep in that everybody's forgotten about it, resurrected, and then just shoot it up through this idea of what if we just extended the crap out of it and then use that to kind of hook dynamic functionality into the kernel? And everybody said, that sounds like a massive security vulnerability. And then we said, don't worry, we're building all of our security tooling with it. So it's fine. But that's, a massive paradigm shift. That didn't take decades. Linux took decades. That took like 4 years, almost, it feels like. That was almost instantaneous. That was that volcanic eruption. But if you think of maybe another different path of things finally getting compacted, and then we are able to build more and more on top of. A really fun example of that would be, do you remember back in the day when people deeply and seriously thought and argued and fought on the internet about whether or not threading was an application level concern or a library level concern? Nobody ever would have seriously said that threading, multi-threading in your application was an operating system concern. Nobody would have ever said that. Even multi-process was, for the longest time, your problem. And at some point we said, okay, well, we have these concepts. We're going to have multi-process. Cool. We don't have mainframes anymore. We're going to take them, but we're going to build on top of that. What's the next step? Multi-threading. Okay, what's the next step after that? And then we have these weird concepts of how do we slice up the program. And now we have this, because thread is in the kernel, you can do really fun things like green threads, or these opportunistic concurrency evaluations that modern programming languages have. This event loop, these weird things we take for granted, would have never ever been possible if someone hadn't had the ridiculous idea to stick an application level concern and bury it down. But that's just kind of how progress works. That's how we ratchet to the next step. And speaking of that ratcheting, good news. We are super, super, super duper good at cumulative culture innovation. Humans are so good at it that we have become the world's worst virus because we're so good at this. We suck at everything else, but we're good at this. I can write an article that says, here's a list of 10 things we suck at. Doctors hate her, and then that idea spreads like wildfire. Where did I put that list? Oh, we took, ones and zeros, pulled them out of the ethers of the universe. And just 1,000 years ago, we were baking rocks. We're really, really good at this. Every other animal has nothing on us for this. The problem is, that is pretty much the only thing we're good at. So if you think of even the other type of innovation, we're really bad at this one. So actually, it turns out there is one of my favorite studies that I've ever seen, where someone was trying to study the concept of, can humans invent tools? Are we good at inventing tools? And so they took a bird and a toddler and said, who's gonna win? And the bird smoked the toddler so bad, it was embarrassing for the entire human race. So if you take, no, seriously, if you take a tall glass and you put a treat in the middle of the glass, and then you give the bird, a pipe wire thing that it can bend, or a toddler the pipe wire thing that it can bend, but you leave it straight so it's useless. And then you just give it to the bird, and then give it to the toddler, see who's gonna win. The bird will figure it out hours before the toddler will, at like 80% higher rates of success than the toddler. It's embarrassing. However, one really cool thing, the cumulative culture thing, if I just sit in front of a bird and I bend the wire and then straighten it back out, that does not really change how quickly the bird figures it out. They innovate naturally at pretty much the same rate and better than we do. But if I take the same piece of pipe wire and I bend it in front of the toddler, I don't need to use it. I just need to bend it. I need to show them that it's possible to bend it. If I bend it in front of the toddler, almost all the toddlers, with astonishing speed, astonishing quickness, and astonishing effectiveness, they go, oh, we can bend it? Oh, hell yeah. And then they get the treat out of the class. And they teach their other toddler friends how to do it. So all you need to do is show one toddler in a whole preschool how to bend the wire. And then within minutes, everybody will be stealing cookies out of the cookie jar. All of them. Humans are really, really good at everything. And by everything, I mean literally only the one thing, which is cumulative culture. But by being good at cumulative culture, we end up looking really good at all the other stuff. The problem is, I don't know if you've noticed, but we literally only care about this one. In society, we go, the lone genius, who heroically figured out the secrets to the universe all by themselves with a $20 million loan from their parents and a world-class college education, but by themselves. Oh, we romanticize that. Why? Or we go, you know what this project really needs? A selfless, dedicated, single, tired out, burnt out person to remain in a hole forever and only do it by themselves. So let's take that concept and wrap it up to a business model and call that venture capitalism. And that's going to be what we stick the entire world's economy on for 25 years. We really, really only care about the one thing we're extraordinarily bad at. Literally, bird brains are better at this than us. However, good news. So we have bad news, we have good news, now we have fun news. We learn weirdly. We already knew that we were good at the human culture thing, but also we're good at learning in a very, very weird manner. Most species out there, when they disseminate knowledge, even very closely related ones like chimpanzees or other animals, when they learn, when they teach, they emphasize the outcome, they emphasize the product. Humans, when they don't learn the product, they don't really care about it or the outcome. They learn and they teach and they disseminate the process, which is a good thing. That's how all of our incentive structures are based around processes instead of outcomes, right? Okay, we messed that one up, but there's still time. The other really, really weird thing, the other really, really fun thing is our social learning rewards conformity. So what that means is if you take several different groups of basically any other species on the planet and they learn something or they innovated, they did that. The other groups don't care. We're humans. We have such a strong groupthink mentality, such a strong in-group, in-thinking sort of drive that if someone were to cure cancer, but they did it in a way that we didn't like them, we would rather not learn how to cure cancer than learn how to like someone we don't like. Like, sure, you cured cancer, you invented it, but you didn't do it in a way that we liked it, so screw you. And then maybe later, we'll be ready for it. But humans have such a strong groupthink that what it does is it causes a couple of weird side effects like world wars. But the other cool thing about it is this eventual conformity creates a situation in which we really, really want everybody to know it. We really want everybody to be able to understand it. And so what we do is we build concepts that everybody gets. And if they don't get it, we change the concept until they do. We reframe it, we reword it, we innovate it, we iterate on it, we modify it, we compact it down, we compress it until all of humanity is bought in on the thing. At no point do we go, the humans over in this side of the world can learn how to do, commerce. We don't need commerce. We figure out how to make it work for everybody in the world, or die trying. Hence the World Wars. But it is extraordinarily effective at modifying this learning, modifying this knowledge approach to where it fits everybody. And that compaction is deeply crucial to the learning process. It's also so unique to humans. It goes back to kind of the one thing that we do well is we are willing to change the fabric of knowledge itself so that all of us can learn it. And that is a strength we should lean a bit more into as a society. But you did want rocks. So, back to geology. Compaction. If we think of this compaction process, I gave some examples, but what are some things that you can think of for open source and the concept of compaction? Just think about it for a minute. So imagine, it's the year 2002. What is the most unbelievable statement you can make to a Linux kernel developer? in statement number 1. We stuck a VPN in the kernel. Imagine, like, literally anybody back in 2002. Multi-threading was not a thing yet. But a VPN in the kernel? Are you serious? And now we have WireGuard. Everybody likes WireGuard. And WireGuard has enabled so many wonderful, amazing things. And people are still figuring out back in 2002 how normal computers work. And now we have nested virtualization with 18 different types of hardware virtualization pass-through because optimization, and it's wild. And then, I joked about this earlier, but what if we made eBPF even more of a security risk, but for security reasons? Just imagine saying that statement to a developer back in 2002. We stuck a giant black hole exploit in the middle of the kernel until we made every system call hook into it like 5 times. Don't worry, this is A, performant, and B, good for security. Just ask CrowdStrike. Actually, one of the reasons that CrowdStrike blamed the Windows thing on was the fact that Windows doesn't have eBPF, or a concept like that to build that type of functionality into the kernel. So it is a two-way joke. To just point that out. And then also, have you ever seen the landscape CNCF wall of nightmares? Just imagine explaining that to a Linux kernel developer who, at their best, are like, oh yes, companies run software. They run 2 softwares. Sometimes you can get them to run 3 software. But no more than 3 software, that's too much. They run 1 software over here, and the CNCF landscape. Bajillions of software. Ever growing, ever expanding, never compacting. But in cementation. So cementation is when after things get compacted in it, something kind of becomes that glue and weaves in through it, and 2 different related concepts that are now deeply close together become fused as one. People can think of it as one thing. What does that look like in open source software? One interesting thing that I like to think of is we had BSD jails, we had Solaris zones, we had ways to isolate processes from each other on the computer. And then someone came along and he said, these are all great, but what if we did this in an extremely overcomplicated way in the Linux kernel? Let's create namespaces and then never use them for any of that flexibility and only keep them around for the security escalation parts. And then they called that containers. And then someone said, this is amazing. What if we made all of the security options in containers really, really bad ones by default? But it looks really, really close to Vagrant. We're going to call it Docker.
Yeah.
And then everybody said, this is amazing. And then, so at some point, remember how I said there's a whole bunch of Linux namespaces? There's like 8. When's the last time you ever thought about the fact that a container is made up of 8 different namespaces in a trench coat? At some point, they got fused together. And from then on ever after, you are never really able to separate the concept. Even now, being able to share networks between containers is actually a capability you can technically do. Nobody ever does it. You can build, nested, real-time, a whole bunch of other fun things. You can do process script sharing. You can do socket sharing. Nobody ever does it. You have this cementation. It just happened. And now you're stuck there. And you can build on top of it, which is great. Maybe we lost something in the middle, but you can build on top of it now. That's kind of the important thing. But what does cementation look like in open source? And how do we, rather than having it accidentally happen, how do we intentionally allow it to happen? How do we really, really think about the cementation process and encourage it to happen? In fact, actually, what if we think of process more than the product? What does it mean for software to die? What does it mean for a concept, for an understanding, for an idea to be maybe a bit more important than the thing that it was initially encoded in, than the binary that first shipped with it? One of the things that's really hard about how we've done things originally is we've tied the concept of funding, security, health insurance, a whole bunch of things around you build one product and then that product lives forever. And the idea associated with the product is tied to it. And we no longer have this cementation process. But back in the day, cementation did kind of happen. This compactification did kind of happen. We had how many variations of cells out there? People used to have millions. And now we have bash and G cell and miscellaneous. And if you think of kernels, how many kernels did we used to have? 20? And now we have Linux and miscellaneous. And if you think of, so we have actually built these compactions over time, but we have never really done it without devastating damage to the communities that were involved in these projects. And that is heartbreaking because the thing that humans do is they share processes, they share how to learn, they share the ideas, they work together to build something beautiful. And that's deeply fundamentally how we work. And so, if the only way that we as humans can grow is by hurting each other, the cognitive dissonance of that is going to be so damaging, it'll prevent us from learning, which is the only thing we're good at. And I don't really like bending straws. So, we should figure out how to learn in a way that does not prevent things from being absorbed. It maybe even facilitates this absorption, this compaction. What does it mean for a project to graduate into not existing? But somehow, through doing that, everything in the world is better off for it, including the communities that built it in the first place. What does that mean? How does that work? And so one of the things that I do in open source is I think about that problem. I think about it a lot, and sometimes it keeps me up at night. It's one of the most foundational problems of the last couple of decades. We just don't have a good answer for that. We don't know how to do it. We've tied all of our funding and all of our inertia. We've built up all these abstractions around making it really, really hard to learn without damaging other people. But the only way we learn is with other people. So we have built up a society that relies on trillions of dollars of economic commerce going through a system that is incapable of evolving, that is incapable of meeting the needs of the people, that is incapable of allowing humans to be humans. And we wonder why we're in the mess that we are. So how do we fix that? And I don't really have a good answer for that. But I do think we need to start thinking about it. And so, going back to the volcanoes, going back to the mountains, these are kind of the two big visible manifestations of the different types of innovation. The volcano is this rapid, spurious, spontaneous, weird and often weird and often destructive innovation. It's this happened so quickly, it's a paradigm shift. We don't even know what happened, but the entire landscape just looks different now, and now we're in it. Those can be really cool. They can be really fun. Maybe don't build your entire economy on making those the only thing that happens. Because if you do that and you live in a world where you only have volcanoes, the last time we wrote fiction about that, we called it The Lord of the Rings, and that was the bad place. But then there's mountains. They take a while to build, but they're built layer by layer. And by the time we can see them, they have been building, they have been growing, and on top of the mountains, we have entire communities, we have cities, we have people able to build them and grow them and scale them and reshape them and create a magnificent world that we live in today. And volcanoes are a part of the world. But we should not neglect the mountains that we live in and that we love. And as I think about what we need, how can we as a society build this cumulative culture rather than just a solo culture? And then use that cumulative culture to actually genuinely make the world a better place. Because as the grains of sand become stones of our foundation that we build the world on, so too must our ideas be cumulatively formed into the foundations of our future.